So here I've already gone through and answered question 2, which was to fill out the table based on what we have here. So we know that if we have dice 1 plus dice 1, we end up at 2. And then like if I take a die comes on 3 and on 2, I bring it down. 3 plus 2 is 5. So that's how this table is filled out. So I've got all my values here filled in. And if I look, the lowest value possible that I found was 2, and the highest value was 12, and it was every whole number between 2 to 12. So if I think about, well, why is that the case? If I think about what's the lowest two numbers, 1 plus 1. So I can't go lower than 2. And the highest two numbers are 6 and 6, which is 12. So 2 through 12 are all my options. So then the question is, well, how often does each of these show up? If I look, and I can actually look at it, here's 2, and I'll go through and actually, 3 only shows up twice, 4 shows up 3 times, 5 shows up 4 times, 6 shows up, here you can see 5 times, and then let's pick a new color here. 7 shows up the most with 6 times, and then if I go backwards, 8 shows up 5 times, and then 9 shows up 4 times, and then 10 shows up 3 times, 11 shows up 2 times, and 12 shows up 1 time. So there's a symmetry as to how many times they each show up. So when I think about what's the best number to play and what's the worst number to play, if I'm going 1 through 12, the worst would be the number 1, because there is no way to score 1. And the best would be the number 7, because it shows up 6 times. The other thing that was asked up here was how many total possibilities. Well, if I add that all up, I can see this is a 6 by 6 grid. There's 36 total possibilities, which means that I know that the probability for each of these would just be how many times does the number show up out of the 36 options. So my best is the number 7, and it would have a 6 out of 36, or 1/6 chance of being rolled from the 2 die. All right, so let's look at that fourth and final question. So it says you're given 5 chips, and you can place them over multiple sums or all in one sum, and they'll stay their entire game. And we're going to roll the dice 10 times, and if I get my number on a sum, I get all the points based on the number of chips. So if I put all my chips on the sum of 6, if 6 is rolled, I get 5 points. If 8 was rolled, I get 0 points. So I do that 10 times, and whoever wins is the person with the most points. So I want to think about where's the best place to put my chips. And I want to use the ideas of probability to help me out here, which is that if 2 events are equally likely to occur, they have the same probabilities. If the probabilities of an event is the sum of the probabilities of each outcome that makes that event. And then the last one, the empirical probability will continue to come closer to the theoretical probability as we do this more often. So I want to think about where am I having my best chance, my highest probability of winning? Well, that's when, if I go back and think about it, my best chance is on 7. Because 7, I know that the number 7 has a 1 in 6 chance of being rolled. So I'm going to say the probability of 7 is 1/6. So if I think about all my other chances, that 1/6 is my best option. Now, you may think that, oh, maybe I should spread them out because the numbers are more likely to occur that way. Yes, there is more variability in your numbers, but where do I have a better chance of actually landing my number than at 7? 7 has the most chances, has the most opportunities. So if I put all 5 of my chips there, I will have a 1/6 chance for each of those chips to be pulled. But if I think about, well, what if I change them out? One chip, as I say, I put 3 chips on 7, 1 chip on 6, and 1 chip on 8. Well, my 3 chips, I have a 1/6 chance, but my chip on 6 only has has a 5 out of 36 chance. It's an even lower probability. So if I think about them as being separate chips, not even that it's 5 chips I have, but if I take one chip, where do I have my highest probability for that single chip? It's on 7. Let me take my next chip. Where's the highest probability that I could win with this single chip if that's all I had? I'm going to lay it on 7. And you do that for all 5. You think about them separately, not as that you have 5, but always about that single chip and where do I have my biggest chance? And it's when I take that single chip and put it on the number 7.